Okay, for today, I'm just making a short video after the end of the day because unfortunately during the day I was not able to get a video recorded. So I'm just giving you a brief idea of how to set up some problems as a review day on word problems. So let's say that we had a rate. Let's say I am picking carrots, and I pick carrots at the rate of 7 carrots per minute. Maybe that includes cleaning them off. Anyway, for whatever reason, that's my rate, 7 carrots per minute. There's an unknown person picking carrots next to me, and I know that when we're all done, that there's a total of 35 carrots were picked over the course of 3 minutes. The question is, what was the rate of the unknown carrot picker? Well, I don't know what it is, so I'm going to put an X. And you get that's the exact same thing as if I put X over 1. And that would mean that I'm going to find a rate per minute this way. All right. Now, if I wanted to change this to a more difficult problem, instead of just what's the rate of the unknown carrot picker, I could say in 5 minutes, how many carrots could the unknown carrot picker pick? And then I would say out of 5 minutes. All right, so those are pretty tough to set up sometimes. Let's say I just wanted to find that rate of my unknown carrot picker. I'm going to start by multiplying everything by 3. I'm going to multiply this by 3, and this by 3, and this by 3. And I hope you know why I did that, because I want my denominators to cancel. All right, so now I have 7 times 3 is 21, plus 3x is equal to 35. Now I'm going to subtract 21 from both sides, and I have 14, and then divide by 3, and I have x equals 14 thirds. What does that really mean? X is a rate of carrots picked, and if I say, I could say you picked 14 carrots in 3 minutes, or you could think 14 divided by 3 is 4 times 3 is 12, and there's 2/3 left, so he can pick 4 2/3 carrots per minute, as opposed to I was picking at 7 carrots per minute, so it looks like I was doing a pretty good job compared to the unknown carrot picker, who's only getting 4 2/3 carrots per minute. All right, so that's just a typical rate plus a rate equals a rate type question. Now here's another one that you'd need to know how to do. Distance equals rate times time. It's a great system for solving equations, and I'm going to make an equation setup for this situation. Let's say that I have a river, and the river that I'm going to paddle on has got a current going downstream. I don't know how fast it is, and that's one of the things I want to figure out. Is how fast is the current going downstream? We'll keep the distance that I travel here simple. It's a 1 mile. And don't worry about the curves. Maybe we factored in the curves. It's a total of travel time or travel distance of 1 mile. Let's say that I'm going 3 miles per hour in my paddling, but I'm getting assistance from the current when I go downstream, so I'm going faster than 3 miles an hour downstream. And I'm going slower when I move upstream, so it's not 3 miles an hour, it's 3 miles an hour less the speed of the current. So subtract off the current speed. Then let's ask the question, if it takes me 15 minutes to get down the river, then how fast is that current? And secondly, if it takes me 15 minutes to get down the river, how long is it going to take to get up the river? All right. If you're trying this at home, you should try to set this up now without me and pause me. Okay, so here we go. The distance down the river is known, and therefore this is my down the river trip, and this equation is going to be for my upriver trip. All right, down the river, it's 1 mile distance. My rate is 3 miles per hour, and my time is 15 minutes. What did I forget? Well, for one thing, that 15 minutes needs to be changed into hours because all my rates are in miles per hour. So that 15 minutes is 1/4 of an hour. Okay. Now, my rate can't just be 3. With the current, I'm going faster than 3. 3 plus c. Now, on my equation that I just set up there, 1 distance is equal to rate times time. 1 equals 3 plus c times 1/4. And that's an equation you could just solve. If I wanted to write it out with decimals, it would be 1 equals 3 plus 3/4. 1 equals, I'm just multiplying this out now in my head. 3 times 1/4 is 3/4, or 0.75. And then this times this, and that would be plus 0.25 c. When you solve it down, I'm going to subtract off 0.75 from both sides. And I get 0.25 is equal to 0.25c. Divide by 0.25 on both sides, and I have c equals 1. The current was 1 mile per hour. Okay, now that's some neato solving for getting the speed of the current. But now how about the time it's going to take me to get back up the stream? Once again, trust the chart. Distance equals rate times time is very powerful. The distance up is going to be 1 mile, and that will be equal to the rate, which is not 3. I wish I could paddle 3 miles per hour upstream. It's 3 miles an hour, but then I have to take away the 1 mile an hour that I'm going downstream. You could put c in there if you wanted, but we do know c is equal to 1 from right here. Okay, and then the time. I don't know how much time it's going to take, so I'm going to call it t. And some people feel like, well, if there's 2 variables, then I must have done something wrong because you can't solve it. Not true. You have 2 equations and 2 variables. So the first equation can be solved. You find out what c is, and you put it in here. So instead of c being a c, I'm going to put in a 1. And now I have 3 minus 1 is 2. So this equation really reads equals 2 times t. Divide by 2. And sometimes, again, you get lost on what this means. T is a half. A half of a what? Well, this is in miles per hour. And t is a time. So it's a half in the terms of hours, so it's a half an hour. So that means the time would be 30 minutes. Kind of surprised me that it takes twice as long to paddle up the stream as opposed to down the stream. But that's the math behind it. Okay, so there's an example of how to set up some of those tough word problems that are in the rational word problems section, chapter 7 near the end. Next week we will spend some time reviewing, and we'll also spend some time on the CAN lab, and then we will have the test on Wednesday right before Thanksgiving. That's all I got for you for today.